technically, it's good morning still, I guess. How many of you were in the keynote? Did you guys enjoy the keynote? Especially the Smart Insights demo? If you remember that demo was about three things: bringing data from production databases for analytics to BigQuery, and then having some interactive visualization from BigQuery with Data Studio. And then we even turned facts into insights by using AutoML tables. We didn't talk too much about BigQuery in that demo, but it was front and center. And this session is about BigQuery. My name is Naoya. I'm from the Google Cloud Singapore team. It was about 8 years ago when I first joined Google. That was about time when this technology called Dremel was about to graduate from a Google internal tool into something that we can offer to customers as BigQuery. And I remember that at that time, the challenge that we had tried to overcome with this technology, it was really astonishing how we're tackling this, how we're approaching this. And since then, for 8.5 years, BigQuery has been one of my favorite services from now what's called Google Cloud. Does anyone want to see more live demos? Yes? Sorry. So, unfortunately, I'm not preparing live demos today for this session, but just outside, there is a serverless data warehouse demo, and there are also other demo booths that you can see, actually ask questions also about BigQuery and the related products. But I have something better for you. I do have a co-speaker that will be sharing their experience with BigQuery, and I'm sure that real-life case studies is what is more interesting. So let's get started. So just to step back a little bit, the amount of information that is around you, the amount of information business has to take in is just increasing. We are generating a lot more data. We are capturing a lot more data. And the question is, how are we going to get insights from that? Well, traditional data warehouses were not really designed for this growth. Right? They were designed for more known data types, known use cases. And of course, scaling added more cost and complexity. It's not only the scale side. The way you want to use data is also changing. It used to be that you knew the data, you knew how it's going to be used, but now it's different. There are unknown data that you can just tap into. There are unknown use cases, unknown questions that you want to answer for. So that requires a very different platform. You need to be able to tap into not only your own data, or that can be also across silos in your organization, but also external data. Right? So BigQuery is meant to solve all these problems that we are seeing these days. BigQuery was designed as a cloud-native data warehouse, and it's really more for data-driven organizations in the cloud-first world. So we often use this word serverless. And what does serverless mean in the context of analytics? How many of you are actually in charge of data platforms or data analytics? Thank you. So traditionally, if you really want to do analytics, what happens is on the right hand, there's so much more you have to do just to do the analytics. The blue piece is actual analytics. But other than that, you have to procure the hardware, install the software, configure it, let it scale, and maintain it. With serverless, what you want to achieve is on the right hand, which is you want to spend as much time as possible in actually solving your own problems or asking your own business questions to your data to get your insights. And that is what BigQuery is designed for. BigQuery is not just that. Of course, it has the data warehouse capabilities. It just scales. But we do have unique features that I'll be introducing further in this session. So how does BigQuery work? This is not a technical session, so I'm not going to go deep. But At the high level, there is decoupled storage and computation. And this decoupling is very important. That means you can scale the storage or computation either way or both based on the demand. That means you don't have to have both running all the time, for example, just to make sure that you have the capacity to store the data. And these two things, storage and computation, is connected with a petabit network. This is a network that we have internally in Google inside our data centers, and also is well connected to data centers across the globe. So let's look at the right side. This is where the data comes in. Data can coming in from different data sources. It might be a dump or an export from existing system being batch imported, or it can be live generated events from the business systems being live ingested into BigQuery. So BigQuery can take two. And the users that we are serving is on the right side. Data analysts can be just using the console in the SQL to ask the questions as SQL. Or if you're using BI tools like Tableau, Click, or other tools, these can be used to generate the SQL on behalf of you and instead giving you a visual interface. Or if you are an application developer, you can also talk to the REST APIs so that you can invoke the queries or the data ingestion, all those jobs from external services. So let's talk a little bit about the challenges that BigQuery is trying to serve. So getting data into getting data into traditional data warehouse is complex. Tapping into the data source, going through complex ETL, and then landing into the data warehouse. Also, there is an increasing demand from not only doing batch, but to have more real-time insights. From the data being generated and ingested to the time you get insights, the shorter it is, you can react quickly to the things happening. You can react to internal problems, external problems, and it can be about mitigating risks, but it can be gaining more opportunities. And it used to be that data warehouses were more for closed people, right? A few management might want to look at the business dashboards and reporting, but now with this change of paradigm, you want a platform that can enable everyone to tap into the data. So BigQuery as a modern data warehouse is trying to solve all these problems, and we will look into each of these one by one. So I'll start with data ingestion. So if you are using some of the data, Google services on the right, Google Analytics, DoubleClick, AdWords, or YouTube, the data that is being collected in these services are actually already in Google's data center. If you are to mix and match those data with other data, it's just a matter of configuration. You can let those data flow into your BigQuery. If you are also using external services, cloud services such as Salesforce, we do have a rich set of connectors that allows you to, again, by just following that wizard, to pull that data in. You don't really have to do custom development to bring the data in. If you are hosting some of your applications in the Google Cloud, you might already have data behind it. That might be running in relational databases, that might be running in different forms, and that's a natural thing. There's no single storage that can serve every use case, and you want the data to be stored, optimized for the use case, right? But still, that doesn't mean that you don't want to tap into those data. So let's say you have a relational database, let's say Cloud SQL. BigQuery can also tap into data stored outside BigQuery, and you can use it as part of your query. That is very powerful. Of course, BigQuery's storage is better in performance because it's designed, optimized for the queries, but being able to combine that data in BigQuery with the business data that might be sitting in a database outside in a single query to get insights, that's a powerful feature. We are adding more Google services so that you can use data across. Some of the recent additions has been actually Cloud SQL, and we do have Cloud Spanner in the roadmap as well. Another interesting source of data can be public data sets. Imagine you are on the retail business and trying to see what is bringing customers to your stores or not. For example, in the public data set, there are weather data. That means you don't have to collect your data, ingest your data yourself. You just have to tap into the data that Google already has. This can be through Google actually maintaining and ingesting or working with partners. But you have access to those data, and again, you can mix and match that data to get more insights. And on top of this, in the keynote, we introduced more services like Data Fusion to easily tap into other sources on-prem to bring it into BigQuery. So next, we'll talk about making data or insights more accessible. And making accessible means bringing it closer to the users. So one thing we are doing repeatedly is to try to make BigQuery accessible from the tools that you're already familiar with. That can be, for example, spreadsheets. Google Sheets, Excel can connect to BigQuery. Or that can be the BI tools that you're familiar with. Major ones can be Tableau, Click, or even Data Studio that we provide for free. So end users that don't necessarily have the SQL skills, don't necessarily have the analytical skills, can still tap into that data through the tools that they're familiar with. Making data available or accessible to everyone also brings in a new concern when it comes to access control. BigQuery allows you to share data sets with certain permissions. So let's say you are more on the data analytics team. You are building ETLs and building some reports. You just want to share that. In that case, you can share the data set that you're maintaining with just view access. That means you're just only allowing people to use it. And your team might just have edit access or owner access so that you can maintain that. Fine-grained access control is a key feature of BigQuery, and it ties with a feature called IAM, Identity and Access Management. This is identity management in the Google Cloud, which can also be linked up with your G Suite accounts or Active Directory that you might be using as a corporate. So as an extension of making data more accessible, let's take a look a little bit at BI Engine. So BI Engine was also part of the keynote demo. This is actually a caching layer on top of BigQuery. So the way it works is that you allocate certain amount of caching for your space, and when tools like Data Studio is hooking into BigQuery, it's actively cached in there so that the corresponding request can be served out of the cache. So that makes it very fast, interactive, and that also changes the behavior because you don't have to wait for seconds or minutes for the response to come back. It's instant. Then you can have your new hypothesis, test it, interact with it. Right? So that is BI Engine. This is a screen showing how we have the integration with Google Sheets. So imagine a Google Sheet powered by millions of rows of data. And now you can have pivot tables, functions, everything that you do with Sheets, now with the power of BigQuery. So those of you who doesn't know how to use a sheet or spreadsheet? Probably no, right? No one. So other things that I typically do is like just charting as well. It's very easy to get the data into the sheet, and that makes it accessible across the organization. And the more the organization has access to the data, the more data-driven you can be. So those are more about tapping into the facts. And data warehouse, or the area of analytics, is evolving more to the space of analytics. You want to do predictions. You want to foresee what's likely to happen. In the keynote, we talked about AutoML tables, but we are also baking in features related to this theme into BigQuery itself. So BigQuery ML, or BQML. This is an extension of the standard analytics capability, the SQL capability that BigQuery has. We have extended the SQL so that the process of training a model, hosting a model, everything can be done in BigQuery. So this is a screen. I know it's a little small, but this is a SQL to create a model. Right? So if you want to do linear regression, logistic regression, or maybe k-means clustering, these are algorithms that BigQuery natively supports. And all you have to do is write a query and tell BigQuery what data you want to use to train the model, and the model can be stored in BigQuery. Before this feature, what people had to do was, we have the data in BigQuery, but for the data scientists, they will export the data, do the data science somewhere else, and then bring back the results. The beauty of BigQuery ML is that data doesn't have to leave BigQuery, and you can complete this within a single tool. We are also adding capabilities to bring in TensorFlow models, which means you don't have to, you can have a clear separation of the data science and then let them provide the models and use it in BigQuery. Another recent addition has been the geospatial capabilities. A lot of data, the information that you have is related to location. So BigQuery now understands data types that are specific to location and polygons and lines that gives you more insights and interesting queryability across data. So for example, you can run a query to see if a point is included in a certain territory or not. So real time has becoming more and more a theme. How BigQuery is supporting that? Major things, I think, is two things. One is real-time live data ingestion. You can throw a lot of data into BigQuery and let it be just ingested. You don't have to wait for batch intervals. So if you have a source that is just generating events, there are tools, there are ways to just push that in, and then they become immediately available for the queries. If you have more complex requirements, we also have extended products such as Dataflow, PubSub that can help you with even complex ETLs. Security is something that you can never loosen. This is not just BigQuery, but every single service in Google Cloud, the data is encrypted at rest and encrypted in transit. But on top of that, there's a lot more governance capabilities that we're adding here. For example, when everyone is doing their own analytics, you probably want to know what data is available in the organization. We're adding catalog capability that can scan through the data within your organization so that you don't have to duplicate efforts. This catalog service is going to index your metadata for the data. That means who has created it, what's the access control being set, what are the labels or tags being set, so that you have a lot more visibility into what's available. We also provide integration with DLP, data leakage prevention, which allows you to scan the data to tell if there are any sensitive data. Right? So if you are taking data from social streams, you never know what's in there. If it includes social security numbers, email addresses, names, it's hard to run a query. But BigQuery has an integration with a service that can actually, by following the wizard, tell you if data includes such information. Last but not least, being serverless is really the big value that BigQuery is providing. The real focus is you using the data. You don't really have to optimize the data, re-index the data. You just let the data coming in and ask the questions. And there's a huge operational cost savings in there. There are additional features that allows you to snapshot and backup data. There are some scheduling data features as well. For those of you who are into more automation, please have a look at these features. I'm sure they will help you. So just to recap, I touched quickly 6 different things about BigQuery. One was the automated data delivery into the data warehouse, be it Google's cloud service, other software as a service. We are trying to make it as easy as possible to bring the data into BigQuery. We're trying to make the insights more accessible to your users. And that was bringing BigQuery's capability integrated into the familiar tools. Also, we're building in the foundation for AI and ML. So not just analyzing the facts, but also training models so that you can have insights about what is likely to happen. So BQML was for that. Real-time. So real-time data ingestion, or even BI engine with more of a real-time interactive data access. And then security. We do have the access control, the shareability across the assets that you build in BigQuery. And last but not least, simplicity in the operations. With all these, we're very honored to be recognized as leader in these reports. The details, you can also have a look. So enough of me talking about the product. I'm sure you'll be more interested in learning how BigQuery is actually being used in the real life. So for that, I have a guest. Please join me welcome Pavan from Property Guru to share their journey with BigQuery. Pavan.
Thank you. Thank you, Navaya, for explaining about the BigQuery features and like what are the new advanced features are coming up. So we are really excited and waiting for the new features. We want to use the BigQuery ones. Yeah, so I am Pavan. I'm working as a senior data engineer in Property Guru. So before going to the session, I just want to ask some basic questions, right? Don't worry about those questions, just basic questions, okay? So how many of you know about Property Guru? Wow, quite a big number, thank you. And how many of you guys are used our Property Guru services? Okay, thank you very much. So now I'm very proud for seeing such a crowd are just using the services. Okay, so who don't know about Property Guru, right? This is just like a brief introduction about Property Guru. Property Guru is Asia's leading technology property partner. And we are serving 2.4 million listings and helping more than 23 million users. And we have a presence in 5 countries, Singapore, Malaysia, and Indonesia, Thailand, and Vietnam. Along with this, we are also doing the property awards business, where we are helping the developers to improve their skills. So here, right, I am here to talk about my journey in BigQuery, right? So what are the problems we faced before BigQuery, and how BigQuery helping Property Guru, so on and so forth, right? So now see, let's go into detail. Just take a small my daily life in BigQuery before BigQuery, right? So as a data engineer, we all have problems, right? Everybody has some problems in terms of their technology or development, whatnot, right? So if there is no problems, then we are not exist. We don't have our jobs, right? So these are such problems we faced when we not having BigQuery, right? So first thing is, there is no single source of truth. So before BigQuery, we are struggling to find what is the reliable source to make the numbers, right? The previous slide, you've seen the numbers of Property Guru, right? So those numbers, it will take at least 1 week to bring such a dashboard before BigQuery. So once the BigQuery is in, it's all done in very easy manner. So I want to give an example for the no single source of truth. I'm a techie guy. Whenever the new gadget is released, I just want to queue up in a line. I want to buy the product, right? So when I stay near Tampines, when I went to Tampines, hey man, I want to buy this product. Sir, it's not available here. Can you go to Suntec City? Okay, why not? Then I just travel half an hour, 1 hour to Suntec City, and I just go there. Hey man, I want this product. Came from Tampines. Sorry, sir, we don't have this product, right? It's so frustrating, right? Because like I spend 1 hour of my time traveling from here and there to buy the gadget. They're telling, sorry, sir, our systems are little bit problematic, so we are not giving the exact count. So it will helping. So the problem, right? If there is no single source of truth, how I am frustrated, the people who are using the product will also get frustrated, right? And one more thing is the cluster management. The cluster management, right? Before BigQuery, we have a different levels of services which are providing ETL jobs. Like some jobs are running the data extraction part, some jobs are running the transformation part, some jobs are running for loading part, all these things, right? So the pain point here is, if which is not in one platform, what we are facing is sometimes the extraction works well, the transformation fails. When the transformation fails, there is no data for the marketing people and business people to analyze. So half of my day goes like this, right? Everyone coming to me and asking, hey Pavan, this data is not updated, and I don't know, data is there, but here the data is not there, but the numbers are different from this system to this system. Sometimes even I'm confused, like which system is reliable, right? And one more thing is data sync issues. As I mentioned, the real-time example, right? It's all pathetic, like how long I had to fix those data sync issues, right? And one more thing is many tools and services. Here, for one ETL job, we are using so many services. For example, one service just to load the data from buckets to the tables, and one service to transform the data from tables to aggregated numbers, and one service to connect the numbers to the visualization tools, and some numbers we want to send as a report. So there are many services we are running, right? So how to manage these services? If one service is broke, then it's very tough for me to identify like which service broke and which teams get affected and all, right? So these are all problems we have. So having a problems is very easy because everyone has some problems, and finding a solution is a little bit tough. As a boss, he has 10 solutions to use, but as engineers, we need to spend our time to finalize which is a working solution, right? So in this process, we come up with many solutions, like many tools. We spent half of 6 to 8 months on this finalizing the product and all. Then finally we moved to BigQuery, right? So here, yes, we moved to BigQuery is a good thing, but as an engineer, how easy for you guys to transform from a different system to BigQuery, right? Here, even before going to BigQuery, even I think like I asked so many questions to Google people and my boss, like what will happen if I get this problem? What will happen if I get this problem? So on and so forth. Then I just going through the documentation. Thanks to the Google guys, they have a beautiful documentation which will help you from step A to step Z. There, and one more typical challenge for me is I don't want to disturb the existing system because we are all serving the numbers and reports to the different teams, and we don't want to disturb those teams to doing what their job is, right? So we are using it in cloud storage, which is having a data transfer service. So if you're having a GCS bucket, just go, there's a data transfer service. Just enable the data transfer service, which will sync your data from any other buckets to your GCS bucket. Like you don't need to write a different programs of bringing the data from different buckets to this bucket. Okay, it's very easy for me. Just 1-2 clicks, the data is available in GCS, right? Now the challenging part is how you are pushing the data from GCS to BigQuery. Even before, like, I'm just doing my hard way of Python programming and doing like how to read the CSV file and how to load in BigQuery and all, right? Then I'm just talk to Google as, hey man, like I'm doing these type sort of things, loading, reading the files and loading the BigQuery and all. Then they told like we have a different service in BigQuery. You just go and load the CSVs, and with 1-2 clicks you can make the data available in BigQuery. Oh, it's nice. So then we're just starting using that from GCS to BigQuery data transfer service. Now all the data is available in BigQuery, right? And here, once the data is migrated to BigQuery, right? So how easy for us to integrate the other services we have? For example, like we are using Google Analytics to capture all the website traffic and mobile traffic or everything, and we are using Salesforce for the marketing campaigns and so on and so forth, and Fivetran to transfer the data from MySQL to BigQuery services. So when we are having different types of sources, so all these sources have an easy integration mechanism, just directly they connect to the BigQuery thing. And for let's come into the data analyst and data standpoint, data scientist standpoint, right? For data analyst, they are running a big chunk of queries on top of this in Tableau, writing some custom SQL and all these things. So whenever they're writing, like they are consuming so much of data resources, and they are spending so much time to waiting for the data to load and process all these things. Then how we are helping them? So in BigQuery, we are just writing a different view. How that view help them to pre-aggregated data will be available there. So they'll just connect the Tableau to those pre-aggregated data sources, and they'll just consume it and plot the graphs. And we are using the recommendations and agent insights as a service. So the recommendations, like everyone is talking about ML and AI. So like, yeah, we have to also use that, right? So when we are trying to provide the data for recommendation service, there are several layers, right? So you need to extraction phase and loading phase and doing aggregation phase, then applying ML on top of it, and finally you need to bring out the output and serve as a service. So how we are doing in BigQuery means the ETL part, whatever the time spending by data scientists, right? We taken out that part and we're using, and we are creating those pre-processed data in BigQuery for them. So they'll just bring their model, run on top of the data, and get the recommendations and use it wherever they want. Right? And one more thing is agent insights. Because we are serving our business, helping the customers and the agents, right? So in the agents, whenever they came to property group portal and they post the listing, they want to see how their listing is performing. And they want to know, like, try to change like what's happened in the listing and how to change and what are the things he want to modify and all these things. We are helping them to identify how their listings are performing and how the numbers are accurate by using BigQuery, right? And this is how we migrate to BigQuery. And as a data engineer, I'm mainly focusing on some 4 key constraints here. The first thing is the reliability and scalability and maintainability and security. So here I want to stress out like how we are achieving these constraints using BigQuery. The first thing is reliability. Because if the data is coming from different sources and data is loading every day without any disruption, that is a big reliability for us, right? So when we have in Google Analytics, they have a direct connector which will just connect to the BigQuery. Then we don't need to worry about whether this Google Analytics push the data to BigQuery or not. Just run your queries on top of BigQuery, then the data will be available there. And the next one is scalability. In the scalability, the thing is, in previous setup, we need to many times go into system sim, hey guys, I want to increase the RAM, I want to increase the disk size, these queries are not performing well. Can you help me, like how to optimize this, or so on and so forth. So when we moved to BigQuery, we never ever worried about how much data we are loading, how much people are querying, how many users are querying, because it just load as much data you want and just query it. At present, we are querying nearly 50 to 100 terabytes daily in BigQuery, like which makes like all the teams, like marketing, sales team, we don't need to help them like, hey guys, this is the report, this is the data you want looking for. Just enable them and self-serve. We can use this BigQuery as a self-serve platform for them. They'll just come and check out this, and that's it. And maintainability, right? We are not touching any server. We are just loading the data, and we are not worrying about the infra, and we are not worrying about the RAM and data storage. Just dump the data and use it. And the final thing is security. In security, we are using, Google has the IAM roles, and they have custom IAM roles. So in the custom IAM roles, we can customize the teams based on the roles. Like, okay, only marketing people just view this data, and business analyst people only view this data. Because of the security, right? So as a data engineer, we have full control of the data, and if any data breach happen, they just focus on data engineers. Hey guys, you done this big mistake, right? So how to secure this? So we are just giving only access to read-only permissions to different groups and different teams, team level permissions.